Hi guys, welcome to your first revision screencast on anatomy and physiology. So what we're going to be starting with is we're looking back at the skeletal system, so the effects of exercise and sports performance on the skeletal system. Throughout your time doing this screencast, you can go onto the tables and use the worksheets that are there. You can also do some quiz trade if you need some kind of help with remembering certain parts of what we're going to be doing. What you can also do is if there's a part of it or an aspect of it that you really struggled on, you can write down in your notepad kind of the area you struggled on so that you've got some extra revision to do at home in your own time. Okay, so first of all, this is the specification of the skeletal system. What we're going to be covering in today's revision screencast is this whole section here. Now, what you want to be doing as you're going through it, you want to almost be ticking them off to make sure that you get them. You might even want to copy this down and tick them off as you've done them, or put an X if you found it quite difficult and something you're going to have to go back to. As I said, this is what we're going to be going through today's screencast. Next week's screencast will be going on to joints. I'll try and get all of that done, so it's just 2 lessons doing skeletal system. So this is how you're going to hopefully get success within the exam. Okay, so first of all, you're going to be looking at the question. You're going to be looking at the mark allocation, so 4 marks, 2 marks, 10 marks, however many it may be. You're going to circle the important information within that question, the vital information that you think that's relevant. I remember actually as a memory method we've got for that. It comes down to this point here, memory method. From the memory method, you then obviously have to translate the memory method used. You can do this on the side of your paper. There's no problem with doing that at all. And then finally, extend your answer with an example. So just to start off with structure skeletal system, what I want you to do is if you just pause this now and you just answer, fill in those blanks so that you've got them down, give it a go. So that's what you should have as your answers. You don't need me to obviously go through them. There are obviously more bones you need to know than that, and they are on the specification if you want to rewind it and have a look at the other ones you need to know, or go onto your piece of paper, your revision notes, your own trigger and answer slides. You can use them, that's absolutely fine. So, okay, next thing we need to be aware of are the types of bone. Now, as you can see, you might get a question saying describe the types of bone, describe 2 types of bone. What I want you to do, at the moment, you can see that I'm giving you fill in the blanks, so it's going to kind of like help you out a slight bit. Closer towards your exam, hopefully you should know this without any information. We're going to do the types of bone, example of the type of bone, and the actual function of these types of bone. So again, if you pause this and give this a go, and we'll move on from there after you've done it. So answers you should be having, we've got long bone, short bone, flat bone, irregular bone, sesamoid bone. Now, long bones, examples, femur, humerus, tibia, function, movement, support, red blood cell production. The reason alpha for movement is it gives us support, gives us structure. Our muscles actually attached to our bones, and that is how we actually get movement, lifting up your arm, running in sport. Red blood cell production. Red blood cells are vital as they carry hemoglobin, which carries oxygen for us. So short bones examples are your carpals, so kind of like in your hand, your wrist. The function is shock absorption and weight bearing. Weight bearing in a handstand, shock absorption if you fall over in sport, you land on your hands. That is what your carpals are for. They're nice and short and quite compact. Flat bones, scapula, cranium and pelvis. Function, muscle attachment and protection. Protection, cranium protects your brain. Irregular bone, you've got your vertebrae. They are your bones of the spine, and they offer protection. What do they protect? They protect the spinal cord. Sesamoid bone is an example is your patella, and the function is to reduce friction across a joint. Okay, or reduction of friction across a joint. So there's a typo there. So that's types of bone. Here's an exam question. Give that exam question a go. If you pause this, give the exam question a go, and then we'll move on. Here's the mark scheme. So mark your own work. See if you've got that. Again, if you struggled with some of this, it's potentially an area you need to go back to. Areas of the skeleton. I want to answer this question first of all. What are the terms used for the parts of the skeleton coloured in blue? Again, another typo, apologies. So basically, what is this known as, this part here? And then also, what are these part known as? These have 2 different terms. What I also want to know, what bones make up the area of the skeleton in blue? Just on this skeleton only. So what bones make up that skeleton? So again, if you pause this please and then give that a go. So answers we should be getting: axial skeleton, his nose made of the cranium, sternum, ribs and vertebral column. And then this one is your appendicular skeleton, okay? Vertebral column, can you name the 5 sections of the vertebral column and how many bones make up each section? Once again, I've given you a memory method to help you out there. You're not going to get these in exam, you're going to have to remember them. So if there's a question on the vertebral column, remember the memory method: cute teddies love some cuddles. So if you can answer that for me, just convert those into the sections that you think they are, again with the numbers. We had a kind of memory method for the numbers as well. Get that down, then I'll give you the answers. So cervical spine, thoracic spine, lumbar spine, sacrum and coccyx. Remember the memory method, it wasn't such a memory method, it was just almost like the rhythm of the numbers: 7, 12, 5, 5, 4. The 7, 12, 5, 5, 4, they're the numbers. That is how many vertebrae there are for each section. Once again, this was an exam question that we were given. Can you give this a go? Don't use your notes. If you can, perfect. You don't really need to look at this again in your revision because you've got it. If you can't, you might put an X on it, something you might have to revise. You can use the quiz trade cards that are on the table to help you out, or the worksheets that are available. Describe the process of bone growth. Now, there's no memory method for this, so I'll give you the key words that you need to have within your answer. Think of this as a question, because this was one of the questions in one of the exams: describe the process of bone growth. Give it a go first of all without anything if you think you can. So pause this right now if you think you don't need any help whatsoever. Then we're going to move on. If you think, you know what, I need the keywords, we'll move on to the keywords. So we're going to go to keywords now. So we've got ossification, calcium, osteoblasts, osteoclasts, epiphyseal plates and epiphyseal line. Remember, osteoblasts build. That's how you remember what osteoblasts do and osteoclasts do. Osteoblasts build, osteoclasts cancel, i.e. destroy. Okay, if you're still struggling with regards to an answer for this, we're going to move on to the next stage. We're going to do a fill in the blanks, a part of the answer mark scheme that we've got. So you can move on to here with the keywords, hopefully be able to fill in almost like the blanks of what each one of the keywords actually does. So there's your fill in the blanks. Once again, if you can, pause this for me now and give that a go, and then we're going to be able to mark our work. And there's your answer. So bone starts as cartilage and it hardens through ossification. That gets 1 mark. Osteoblasts form new bone, i.e. build new bone. Osteoblasts build. Osteoclasts absorb debris or break down the old bone. Osteoclasts cancel, destroy old bone. And epiphyseal plates or growth plates are the size of bone growth, seal off once bone is fully developed. Okay, what are the main functions of the skeletal system? The memory method we used for this, once again, this could be an exam question. What are the main functions of the skeletal system? Memory method we used for this was many people like running, biking and watching sport. Okay, now within that, running and biking, there's potentially 2. And once again, can you actually think of what they are? The M, the P, the L, the R, the B, the A, the W, the S. Give that a go. Just jot it down. Just identify. So for identify, literally just list. Make a list of what you think they are. Pause it now. Do that. The list. This is what the lists are. We have mineral storage, protection, leverage, reduces friction, blood cell production, attachment, weight bearing, support. Now, can you give this some sporting context? So actually, with mineral storage, can you develop this a bit further and explain what minerals are stored and why this is beneficial? Remember, this is to do with the skeletal system. When we're talking about the skeletal system, it is the bones. So mineral storage, what minerals are being stored? Do we think now, and why would that benefit a sports performer? So if you pause this, give that a go, and then we'll move on. So if you're going to apply it, you have store of minerals. So calcium, essential for bone repair. Okay, basically what this means is you are going to be less likely to be injured with regards to something like a fracture. Ignore this here, I'm not quite sure what that's doing there. Okay, protection. So protection, in sport example, would be a tackle in rugby or fall during running. Part of the skeletal system is protection, as we said earlier, on regards to the bones. Leverage, so it offers leverage. So bone length will determine sporting performance. A tennis player with long limbs will generate high force when hitting the ball. reducing friction across the joint. Patella, which means you're able to run for a long period of time without knee pain. Source of blood cell production, probably red blood cell production. Okay, so red blood cells carry hemoglobin. More hemoglobin, more oxygen going to the working muscles, which means you're going to be able to perform for longer, higher intensities. You've also got white blood cells, which help fight infection, keeping athletes healthy. Attachment for skeletal muscle, so movement produced during sport, like kicking football. So if you kick a football, your quadricep muscle will contract. It's attached to your femur, so therefore it will bring your femur forward and generate power to kick a football. Weight bearing, carpal support body weight during a handstand. Support, provide framework so we can produce sporting movements. Okay, so that is what we have with regards to those ones. What I want you to do is look back at anything you found difficult or think you're going to struggle on and revise that some more. Thank you. Bye.